Hello and welcome. Thank you for joining us today. My name is Ashley Manns. I'm with Atlas Copco Tools and Assembly Systems here in the U.S. I'm the segment leader in our sales team dedicated to the motor vehicle industry, and more specifically to that, I'm the segment leader for our automotive tier supplier customers that we work with. Today we'll be going through some of the general trends related to the future of assembly as digitalization in production becomes more common, and then I'll introduce you to our latest concept that supports the digitalization of production, and this concept is called Smart Connected Assembly. And it's really through this concept, the Smart Connected Assembly, that we're going to show you and describe to you how our products and services that we already have today can support the vision of Industry 4.0 and where we bring the values for our customers as it relates to production. Before we can go into any specific concepts, I think it's important to take a step back, because to understand where we are going, we need to understand where we are coming from. As many of you know, Industry 4.0 is a term representative of the fourth industrial revolution that really has already begun, and we're seeing it now in its infancy stages. But how did we get here? How did we get to the fourth industrial revolution? I think let's take a step back. Let's look at the innovation through history that has been driving us to this point by taking a look first at the very first industrial revolution that was marked by a shift from people making things as individuals inside their homes and in one-man shops to factories and mass production that utilized special purpose machinery powered by steam engines, and really lent itself to enable the second industrial revolution, which we're probably all most familiar with is we still live and breathe in assembly lines today. And with this second industrial revolution came mass production being further enabled by the assembly line. The third industrial revolution took that assembly line and that mass production through it and introduced electronics and IT to further automate production processes. And this third industrial revolution is really where we've been since about the 1970s. And that brings us to our current state. Experts are saying that the potential with things like connected devices and big data, the fourth industrial revolution is here. What this fourth industrial revolution will bring is the use of cyber-physical connectivity, these systems that will now truly digitalize mass production with their use. And I know most of our companies are working towards a strategy to adopt and adapt Industry 4.0 into our operations. And Atlas Copco wants to be a part of that. We want to support you in your journey towards Industry 4.0, and how we do that with the products and services that we have here and now already available, and the value we bring in doing so is something we're going to get more into in this material. But first, let's talk more about Atlas Copco's experience and knowledge in these cyber-physical systems that will be so important in the digitalization and production going forward. When looking at smart or connected devices, Atlas Copco has more than a decade of experience delivering smart devices, and today we have more than 15,000 wireless tools and operations. So with this, we have gained not only knowledge in how to design and produce smart devices with battery and wireless technology, but maybe even more important than that, we've gained the knowledge of what it takes to actually deploy this technology and get it up and running to meet our customers' production demands. And then going one step further beyond connected devices and into the big data realm, we look at our 15 years of experience in data collection and analysis with over 60,000 connected devices, which has allowed us to gain insight not only in how to develop software for data collection with the right communication protocols, and then optimize the user interfaces, which is actually something that we have done with our latest generation data collection software. But this has also given us the knowledge to understand what it takes to maintain data over time with archiving and upgrades and the analytical tools that are needed to really make sense of it all. So between our over 15,000 smart devices already in production today and our over 60,000 connected devices, we have a solid platform both in product and in knowledge base to stand on today, but also to build on for the future. Which brings me to the future. Other than wanting to move into Industry 4.0 with all our devices connected and reporting to each other, what else is there to look at? Are there other important factors to consider? And I think the answer to that is of course. Of course, there's other things. There are industry trends and needs that are going on that we have to consider and take into account as well. And we see these four here as really the key components that will drive our customer strategy in the future of manufacturing, and will in turn, of course, drive our strategy as well. And the first of these being a higher product mix. We all know that consumers are expecting products to be customized to meet their needs, as well as being competitively priced and delivered at the same speed as any other standard product. And really, the companies that are able to do this first in a cost-effective way will be ahead in the game right off the bat. But what this will require is new levels of flexibility in production, and with that need for flexibility will introduce and increase system complexity, which is the next box here. With the production systems becoming more complex and more production critical operations being connected, we will become more dependent on IT infrastructure. And the importance of managing configuration and software versioning and access control will be vital overall to maintain quality control, maximizing uptime in production, and then of course increasing the overall asset utilization of the tools you have online. But as we talk about system complexity, we have to also consider the human factors. And while we are lucky that we have a generation coming up that will embrace the technological complexities, we also have to think about having these competencies, though, all the way through our organizations, not just at the managerial level to deploy and implement such technologies, but at the operator level too, to be able to utilize such technologies. So while we have a generation coming up in the workforce that is very comfortable and confident in using these type of systems, the flip side of the coin is that they're not necessarily used to the manual work side that the older part of the workforce is more used to. However, that aging workforce, which by the year 2020 is estimated to be at about 25% above 55 years and older, with that aging workforce, we have to think about ergonomics and more user-friendly equipment. And a great example of this is the introduction of collaborative technologies to increase overall efficiencies in ergonomics and stations for these operators. And then finally, sustainability. Sustainability is an important factor here as well as in the future, not just because it's important to the financial bottom line or a longevity perspective of a company, but it is also important to all of our brand images and corporate citizenship that we have a solid sustainability plan in place. So knowing all that, we at Atlas Copco want to look at how we will create value in the context of future manufacturing. And to answer that question of how we will create value, we come to our 6 pillars, which are the key areas based on our experience, knowledge, and understanding of future trends and demands that we want to focus on with our customers. And we'll start with the increase in uptime, which I think goes without saying that downtime is every manufacturing facility's worst enemy. It's expensive and very wasteful, so maximizing uptime is of course a pivotal value our customers need now as well as in the future. One example of how Atlas Copco can help increase uptime is to implement asset utilization programs that focus on preventative and proactive maintenance. Moving to the next pillar, we have reduction in defects, another one that goes without saying is needed. The quality demands of all suppliers, whether you're supplying directly to the end consumer, or you're supplying to somebody who's building a product that's going to the end user. All quality demands on all suppliers at every level are becoming more and more stringent. And the overall goal at the vast majority of customers is to reduce rework, minimize scrap rate, and ultimately cut warranty costs associated with defects created in production. Currently, Atlas Copco has the capability to offer in-station error proofing and zero-fault fastening strategies with electric tools, which make it possible to reduce assembly defects considerably. The next one that is another one that's going hand in hand with some of the demands we saw on the previous slide is, as consumers want more customizable options in the same availability as standard and off-the-shelf solutions, we need to have a flexible production environment that allows us to introduce the new product mix more quickly and efficiently. And we can do this by optimizing floor space, reducing station clutter, and having centralized visualization and management of equipment for faster and simpler rebalancing. Improved productivity, the 4th pillar, has been a long time standing pillar of value within Atlas Copco. Now and in the future, we plan to increase productivity, not just with obvious methods like increasing line speed, but really utilizing the data from the line to optimize throughput. For example, using a report out of our ToolsNet data collection software, we can work systematically through those top problems, so to speak, and analyze where the errors are, make changes, and increase overall throughput of the line by making changes in programs, not just focusing on cycle time. Human factors and human interaction, when we consider the aging population that we have by 2020, and then we also consider the next generation of workforce, it's so important that we think about not only ergonomics and the safety of operators, but that we also think about user interfaces, interaction with the equipment, and also operator guidance in general of how people will use things. And then finally, reduction in energy. I think this is an important component of sustainability and corporate citizenship, as topics like global warming and that become more of a corporate call to action. A manufacturer has to minimize their carbon footprint. And one way to do that, and probably the most popular way and most well-known way to do that, is to convert from air to electric tools, which many customers and facilities have already been doing over the last 20 years. But another area that people sometimes don't think about is the standby energy that's consumed by electric systems. When we look at how much time a system sits in standby and things of that nature, we see that 60% of the energy is consumed in standby, while rundown represents 32%, and the actual tightening only represents 8% of the energy consumption. So we have opportunity there to reduce our energy use by maximizing some of that time. I hope those values resonate with you, but you may be asking yourself now, how are you going to bring all those things to life for me so that I can actually realize them in my production facility? And with that question, I introduce to you now smart connected assembly. The future of manufacturing is of course about connected devices and big data, which we'll go into more. But from our perspective, it is more so about supporting our customers in the complete assembly process, which we illustrate here by walking you through from startup through launch of production, maintaining all your tools and asset utilization, introducing error proofing, optimizing the output of the products and ensuring that you have a quality product coming off your line, optimizing things with analytics and with data output, and then of course giving that final traceable output to a process that's been completed properly at the end of it all. Looking more in depth now at some of the critical products that are cornerstones in supporting our smart connected assembly concept, let's start with the new generation configuration software that takes a line approach to providing personnel within the facility the ability to monitor, configure, and manage all stations from one centralized location. For example, manufacturing engineers can ensure that all stations have the right software version, they're running the right parameter settings, and that they've been maintained properly over time, giving visibility that when a change is made, that change can be tracked from what was made, who made the change, and really ensures quality is not compromised when we're making changes, and making sure that that quality is assured at no sacrifice to uptime. From the configuration software now, let's go out to the plant floor level and take a look at this overview we have here, where connectivity and real-time control of assembly process is brought to life through our next generation tightening controller, the PowerFocus 6000. This controller operates as a fog node, which essentially means that it allows for the connectivity and real-time control to happen closer to the physical proximity of the tightening. In addition to that, this controller is capable of having multiple virtual stations. So instead of a hardware box and running one-to-one tools throughout, a virtual station provides the necessary process control in the station. And this concept of virtual station eliminates the need for the hardware in each individual station. These new wireless stations can be added simply by adding new virtual stations onto existing control boxes. What we're illustrating here is this virtual station concept now being brought down to the station. And when you show all the connectivity of the entire assembly line together, we see that we represent a change from value created by boxes and cables to now software and wireless smart devices, which is pivotal in supporting Industry 4.0 and is a cornerstone, like I said before, of our smart connected assembly. And what we're representing here with this graphic, you can see in the white lines going up from the stations and the lights moving around, it's symbolizing the data transfers that are happening. So the process control is happening at the individual virtual station level while the data is being pushed back up and being recorded in a traceable level. Let's go now from the plant floor level that we were just at to a station view and explore how our products bring to life our 6 pillars of value. Superior productivity has long been a value pillar of Atlas Copco. The PowerFocus 6000 is the latest generation of tightening controllers from Atlas Copco. With this new platform, we focus on various value pillars, but specific examples given here include new product introduction, reduction in energy, and human interaction. With regards to new product introduction, the system's capability to add and move around virtual stations instead of physical boxes means faster, simpler, and less expensive rebalancing when our customers are introducing new products. And within that same regard comes reduction in energy use. With the use of virtual stations, there's less energy used by the actual physical boxes consuming electrical energy. And then we move into human interaction. The new interface on this controller has been designed really to assimilate to what most operators and users would be used to now with smartphones and tablets and things like that, is to ease use and also make it more efficient as far as training and things of that nature go. Going now down to the tool level, we look at the Tensor STR series, which is our latest generation of corded transducerized tools. Some values that this tool is bringing now is with use of a physical sensor in the tool, we're able to introduce a new angle monitoring strategy called True Angle. What this strategy is able to do is reduce common assembly problems by eliminating operator influence on the tightening and giving an actual true angle readout of what was applied to the joint specifically. And if we look then now next to improve productivity, we've put a faster motor with better heat dissipation, which should reduce cycle times in most applications. And then going into human interaction. Another new strategy we've implemented with this tool is on the tightening side, and it's called Turbo Tight. What Turbo Tight does is it's an algorithm that is able to reduce reaction force and in some cases reduce the need for reaction arms altogether. Other things that you see on the tool here is what we call an EHMI. Down at the bottom of the tool there towards the reverse ring, you see an indicator right there for the operator getting readout and feedback as to the results of the tightening. And then at the end of the tool are rotaction sockets, which are sleeved sockets to protect from injuries due to entanglement. Moving on to another technological trend, which is towards wireless devices, let's take a look at what we have to offer in this product range and talk about what values you can gain through wireless freedom. We've touched on the virtual station capabilities of the new PowerFocus 6000 a couple of times already, and this here just reiterates that you can expect increased uptime, ease of introducing new products more quickly, improved productivity overall, and then an increase in human interaction with the systems through these virtual stations. Going now to the actual battery tool themselves, our wireless battery tool range, the Tensor STB tool itself, brings value by increasing uptime, improving productivity, and helping customers introduce more products more quickly. And really it's doing so by being a battery tool itself. So not having cable management to worry about, lending itself to more flexibility and accessibility for operators when actually using the tool, being more compact and low weight, maybe compared to fighting with a cable on a tool, things of that nature, really lend itself to these values when put in use. And then now looking at some accessories that are available in the same wireless realm, we look to our latest socket tray that's utilizing power over Ethernet. And with this device and utilizing that, it gives wireless connectivity throughout, but greater simplifies the installation, and when rebalancing comes into play, becomes much easier to move around, helping to increase uptime and reduce the time necessary to introduce new products. And then, of course, reduction in defects. The purpose of the socket tray itself is to help guide the operators through the process and make sure they're doing the correct operations in the correct sequences. And on that same note of reducing defects, we can now look at one of our error-proofing station solutions, what we call a single quality station. And what this solution really is looking to do is help increase uptime, reduce overall defects, make it easier to introduce new products, and give a better human interaction experience with the process in general. When we talk about increasing uptime, one way this system can do so is by putting inline rework right within the screen, so that if a defect happens or something happens in the operation, the part doesn't have to be pulled offline and completely taken to a separate area. It can be done inline now. Reducing defects, as you can see there on the screen, there's a picture of a part that's walking the operator through and guiding them on what they should be doing and the results that they're getting as they're doing the process. Introducing new products with the screen right there with the part details, walking you through step by step. It reduces the need for offline training and really brings the training and getting an operator up to speed, lessens that time and brings it right line side. And then human interaction, it's a very user-friendly touchscreen HMI interface there that most people are very accustomed to using, and the software itself can be easily customized. Going beyond production then, we offer a wide range of quality assurance equipment that also aligns with our 6 pillars of value, and we'll look at a couple of them here. Looking first at our ST wrench, our digital torque wrench. This is a modular and compact design for quality control to check residual torques, perform joint analysis, including joint behavior and joint stiffness. It's also great for prototype builds or low production volumes when accessibility is limited. Going beyond quality assurance equipment just related to joint quality, we now look at machine capability, which can be tested with our ST bench quickly and easily under real production conditions without actually having to need to interfere with production. Which brings all this to data collection. The output from all those connected devices we've talked about so far today is the newest raw material, data. And I've read some industry articles that are changing the adage from cash is king to data is king, or data is gold. And data historically has been used for traceability purposes, and while that's still very important, how we use this data to actively analyze and optimize our production systems in the future is really what is going to be what takes data from being a raw material to a tangible asset like gold. And in doing so, our customers will realize values like increased uptime, reduction in defects, new product introduction, improved productivity in human interaction. Having proper data collection and also being able to analyze it and get a quick output from what all this data means is what is going to give you all those value drivers. And then finally, looking at service, because all of this equipment does us no good if it's not installed properly and kept running and optimized on a regular basis. So from a service perspective, we have a complete range of offerings that support smart connected assembly in these 6 pillars of value we've discussed today. I'll start in the beginning there with startup services. With this service, you can introduce new products more quickly with the help of our trained technicians, and you can ensure that you're optimizing throughput right off the bat while also minimizing potential defects that come off the line with the correct setups. You then move into maintenance. Once the equipment is up and running, we need to make sure it's maintained properly. Asset utilization becomes key after startup. You have to ask yourself, how will you keep the plant running? Atlas Copco offers a full range of maintenance options that are available to help you increase uptimes through properly maintaining all of your equipment. And then finally, moving into optimization. Once everything is started properly, has been maintained, we want to make sure it continues to run properly, but also optimize it to make it better than it was the day before. And we offer a full range of services and solutions to help do this as well. So we've gone through these 6 pillars of value with you a few times. We're focusing, based on what we know from industry trends, on increasing customer uptimes, helping our customers reduce their overall defects, allowing them to introduce new products more quickly, helping to improve overall productivity, ensuring that the human interaction with our equipment and our softwares is excellent, and then of course reducing overall energy use. But in the end, from our perspective here at Atlas Copco, it's not just about connecting devices or collecting data. It's really about how in doing so we will create value that you will benefit from. And we are committed to creating that benefit for you through our 6 pillars of value. And this is what we call smart connected assembly. Before we end, I want to leave you with a final thought, which I wish I could say was my own original thought, but it's actually inspired by a Microsoft commercial I saw during this year's Super Bowl. It's narrated by Common, in which he says, "It's not about what technology can do, but what you can do with it. You're the voice, and it's the microphone." And at the end of the commercial, he asks, "What will you do with it?" And I think that's a really simple question, but at the same time, it's something that we're all working towards as corporations and then individually as well, to understand what will we do with all this new technology available to us? How will we use it to make our companies better? And the journey to answering that question is something that Atlas Copco wants to be a part of. And I hope it was brought to life here with the presentation today with our Smart Connected Assembly concept. And we look forward to working with you in the very near future.